Welcome to I guess yesterday's July 8th LeetCode challenge. I forgot about it, so sorry about that. It's maximum length of repeated subarray. So given two integer arrays nums1 and nums2, return maximum length of the subarray that appears in both arrays. So given num1s and num2, and you want to find the maximum length of the subarray that appears in both of them. So the output bit 3 because we have 3, 2, 1 as a subarray here and here that are matching in both. Likewise, if we're given if nums1 equals nums2, then we would just return the length of the nums1 or num2. Pretty much it. So this one, it's a medium-sized question. It's a medium difficulty question. We're going to solve it using dynamic programming with memoization. So since a common subarray nums1 and nums2 must start with, say, nums at I and nums1 at I and nums2 at j, we're going to create a dynamic programming double array that to be the longest common prefix from nums1 of I, starting at nums1 at I, and nums2 at I. So whenever the index of nums1 is equal to nums2, we know that the dynamic programming array has to be incremented by 1. So the answer will be we're going to return kind of like a monetization. So we're going to return the maximum number of from the DP array. So we're going to do a bottom-up dynamic programming to find the answer. We're going to loop through our variance and then calculate the numbers of I and j stored within our DP array. So how are we going to do that? So we're first going to create a memo, which is going to be an array of an array. So we're going to use list comprehension here. So we're going to make an array of zeros, followed by which is initialize it using the length of let's call it length of b, I guess. So star length of nums2 plus 1. So for blank in range of the length of nums1 plus 1. So we just initialize our dynamic programming type of let's call it DP actually, array within an array. No, I'll call it memo. It's a lot better that way. Okay, for I in, now we're gonna do a nested for loop here. So for I in range of the length of nums1 minus 1, we are going to minus 1 outside. Go in reverse order and decrementing 1 each time. Likewise for j in range of length of nums2 minus 1. We're gonna go to the same thing, go in reverse order, decrementing 1. So if nums1 at index I is equal to nums2 at index j, what we're going to do is that we're going to update our dynamic program memo ij. That's going to be reassigned to memo at I plus 1, j plus 1, plus 1. And then we want to return the maximum from the max of the, let's see, maximum of the row for row in memo. Alright, let's see if this works. Right. I see. There is a range length of, forgot parentheses here. Submit it to see if it works. Alright, so time complexity is big O of m times n, where m is, for instance, the length of nums 1, and n is the length of nums 2, and space complexity is we're storing in a two-dimensional array, so it'll be big O of m times n as well, where we have, as used by the dynamic programming double array. So yeah, I totally forgot about this yesterday. I thought I did it, but turns out I didn't, and that's pretty much it. I'll get around to doing the one today in a bit. Have a nice day.